Hello, welcome back. So in our last video, we discussed advanced topics about classes. Um, so we discussed the relationship, the aggregation relationship, relationship between two classes. And we also discussed the static keyword and the final keyword. And we also discussed the pass by value. Okay. Uh, in the context of the parameter is a mutable class type. Okay. So let's take a look this second example and which covers some of the topics, the concepts that we discussed. So this example is a Java class example 2. It's still about a person, okay? So there are three files, an outfit.java file, the person.java, and the driver, okay? So first, let's take a look at the outfit class. This is new. This is a new class, okay? So this is a class name, and within it, if you take a close look, the first three variables, they are all capitalized, and they are primitive integer, okay? But ahead of them, we have the two keywords, static and final, okay? So this means they cannot be changed because of final. Okay, they are static. That means they belong to class instead of course, they also belong to the instance objects. Okay, but they belong to class, so they shared also by of the instance. Okay, and let's take a look at this one. And this is a little bit of more complicated regarding these types. Okay, it's an array of string, and it's initialized with a different kind of outfit, vest or shirt or polo or jacket or coat, is it? And the types are also static and final, okay? And for those three, they are primitive type. So once they are defined as final, cannot be changed. So 0, 1, 2. Small cannot be changed to 2. Okay, so the value cannot be changed. And for these types, okay, so it's also final, but it's array. So if you recall previously, we say if it's a reference, that just means it cannot point to a new memory location. Is it? So for this declaration and assignment statement, what it means, so here is a heap. Okay, so it has the array, okay, and has like a vest and shirt, polo, like a polo, okay. And so here you have stack memory, and within it you have the types. So types are going to point to this memory location, okay. So what it means that on heap, suppose we have more space, okay, you create a new memory. So suppose this is a heap, okay. So Then this is like, suppose you change it to new vest, something. Okay, great. So will this be able to point to this? So the answer is no, you cannot. Okay, you cannot point to some new block of memory, but you do, uh, it does allow you to change like the vest to new vest. That's allowed. Okay, so that's the difference regarding the final. Okay, then we can test it. Okay, and we have three other instance variable, and they are private. Okay, so they are encapsulated of the other class. They are static, so they are class variables. And they are public, okay, because they shared. So normally you, for class variable, you put them as public, okay. And especially in this case, they are also, the purpose for them is serve as constant. Okay, then the outfit default constructor, pretty straightforward. You assign the type to the type and the color and the size. You can also use an explicit value constructor. So both are pretty straightforward. And we also have accessor. We have three accessors, okay. And because all of them are primitive or immutable, so we just directly return the instance variables value. We can also have the set function, so mutator, okay, the set method. So pretty straightforward also. And as usual, we have the toString overridden. Okay, so overridden from the superclass object. And the same thing for the equals. And we just do the structure equality check. And also overridden from the superclass object, the root class. So that's regarding the outfit class. And then let's take a look at the person class. So person, as usual, this part we already learned. So the new thing is here we have a variable called total count, and we define it as private and also static. So this is a class variable. So it's belong to person class and can be shared by all of the instance of the person. And then if you take a look, we add a new instance variable m outfit. The type is outfit, is the class that we just defined. Okay. And then we also have another instance variable, we call it M parents, but the type is a string and it's final. Okay, so you cannot modify because it's a string that it's immutable, so not changeable. Okay, not modifiable. So that's a general information about the instance variable and the class variable of this person class. And then next, let's take a look. the constructor, okay, as a user, this is just name, age, user. And for the outfit, then you do need to use the new to create the memory location on heap for this outfit, okay. And this is a class variable, and it does count how many person created. That's why we put it inside the constructor, because any person is created, then this count will be increased by 1. It's in the constructor, okay? And here we initialize it, and just keep that in mind, it's final, so the value cannot be changed, okay? But it can be different. So for the second constructor, if we take a look, so this time it's the constructor with parameter. Okay, so you use the parameter to do the assignment. But for the outfit, just be careful here. Okay, so if you take a close look, we create a new outfit, and with all of the values from this parameter. Okay, and the same, this one's the same for the static variable. Okay, class variable. And for this one, you cannot change it, but you can, you see, different person can have different amperance set up based on what you pass in from the parameter. Okay, it can be different. But once it's assigned in the constructor, in all of the other method, you cannot modify it. If you try to access and modify it, it will report error. Okay. So what will be the heap memory scenario for this case? Okay, so the idea is here you have that heap memory. Okay, so here you have some outfit that's created. So this is an outfit. So the P outfit. Okay, so basically, it's a copy from the stack. Okay, depends on the call. Okay, and it will point to here. Okay, so it has color information, size information, etc. Okay, so suppose it's vest, something like that. Okay, and here what we did is, so here you have a local variable called clone outfit. Okay, so what it does, you do call new. So here you call new. That with this new, then you just make the copy of the value. Okay, and then like the size here, and here's vast. You copy and some other information, and then it's point to its own location, but with exact the same value. So this basically is a deep copy. Okay, and because of this deep copy, then whatever in the driver, so in the driver there is an argument. Later on we will see some argument also point to this one. Is it? Then for this person, is it? And you won't change the original if you do anything on this clone, so it won't impact. So won't impact the input parameter because you have the deep copy. Okay, so that's the concept here. And then let's see, the get name, get age, all those accessors are the same. But for this get out of it. So just be careful. We didn't directly return am out of it. We return a copy. Okay. So this is a deep copy of am out of it. Okay. So that we keep am out of it encapsulated. So if there's any malicious coder want to do attacking, then it's protected, okay, because everything uh, is the copy, okay, won't impact the original. And we have a mutator, and here similar set outfit. Is it set outfit? Let's see. For this one, it's a copy, okay, so it won't be the original, okay. So also a deep copy, okay, deep copy, and so the M outfit is also protected, so can't be modified by the by argument from main method. Okay. So this is all regarding secure coding. It's a recommended practice for secure coding. And if we take a look further about the mutator set person, is it? Then for the outfit, similar concept as previous, you need to have a deep copy to encapsulate the end outfit. Okay, protect it. Okay, then set name, nothing change. Introduce self, pretty straightforward. Get self, not change. And for the get clone, yeah, get clone is just you get a deep copy of the of this. So deep copy of this. If you recall, that means object itself. Okay, and the talk is pretty straightforward. And then next is the toString. Okay, general same rule, okay, override from the root class object, and then you just output everything, okay, equal, just do the structure equality check for all of the data members. And you do have this get count, but this method is also class method. It's not instance method. You just return that class variable. Okay, so that's, let's see, some other methods here. Okay, yeah. So the talk method, we also have a static, so class talk method, okay. And over here, we also see if we can change, because if you recall, outfit type, is it if we can modify it, is it? We can see, yeah, you do be able to modify the contents, okay? But if you try to do this, that will have error, okay? You cannot do that. Even though it's, so even though it's final, but it's just the arrow The point you cannot change, but the contents on the heap memory, you can still be able to change. Okay, then let's take a look at the driver. So within the driver, we first create the first outfit using the default constructor, try to output. Then using it, we are not going to use it. Then for the first person, we also using the default construct created. Okay, and we create the second outfit with explicit value constructor. And then we create the second person with that specified clause. Okay. Then we can output to see what will happen. And then you can also check. You see, this get is a class method. So here we do call it using the class name to access it, okay? And if you recall, the talk method is also class method. So you use the class name to directly access instead of the instance variable, okay? Then we also check if the close to and the P2s get outfit. And if you recall, the person to the outfit is created with this close to, okay? But if you recall, when we do create in the constructor, we use deep copy as we do the clone of the outfit. So these two suppose not to be the same, is it? So for this is referential equality check. So it's supposed not equal, is it? Yeah, we will see the running result to confirm our derivation. And let's also check if the clause, the structural equality, the same. And we will say it's the same because close, this outfit is created with that close to, so it should be the same. Okay, it should be yes. And we can also test our try change outfit method to see if it does impact P1's outfit. Okay. And for the remaining, the knowledge check, and you can try it after you learn this chapter. Okay, and next, let's take a look at the running result. Okay. So this is a default constructor for the outfit. Yeah, so it does use of the default values. And then this part is a person, so it does use a default outfit. Okay. And what next it does, it check for the second person, is it? So then the outfit is a different one. Okay. And for the second person, it's going to do the talk. Is it? So here it check if the two outfit are the same. Is it? So yeah, you see it confirm our guessing. Is it shallow copy and deep copy? And then we see if it will change P1's outfit. Is it the outfit you see it's still there, so not get changed. So it won't have the impact. Okay, so that's the discussion, the study about the second class example. So let's stop here for this lecture. And we will discuss the third example in our next lecture.